All right, so as we kind of look at this today, this video, this idea of like thinking about equivalent decimals, and that could also refer to like whole numbers. We're gonna talk a little bit like, whoa, what does this mean exactly, right? And to always break that down first, let's go back to equivalent, right? Equivalent is a very important word. It shows up in everything we do with math, and really it has that sound of equal, but it's not equal. What equivalent means is that it has the same value, so it's worth the same, but it looks different. I think that's probably the best way to do that. And when the most basic example I always like to give is we have a dollar bill, right? It's $1 bill, it's green, it's paper, and it's worth $1. That's its value. It's worth $1, right? And if we had an equivalent piece to that, we could think about, oh, well, what about quarters, right? Quarters are silver and shiny, and they're smaller. And when we have 4 of them, that also equals $1. So if we think about it, they are equivalent because they both have a value of exactly the same amount, but yes, they physically look different. And so we want to think about that with numbers as well, right? So even as general as this, if I had 4, right, there's 4. Well, how else can I show 4? What's equivalent? Well, 1, 2, 3, 4. I can do it with like tally marks. Those are equivalent. They both equal 4. Or here's 4 here, and 2 plus 2, that's also 4. These are equivalent, right? They look different. 2 plus 2 looks different than 4. So this is like that whole idea of equivalent. Like, how do we do that? How about this, right? Again, they're equivalent. They look different. If I have 10 things and I take 6 away, I will have 4. And this is just 4. Like, that is kind of the whole idea about an equal sign and the way we balance equations. Now with decimals, one thing we have to keep in mind with place value is, remember, decimals are a part. They're a part of things, right? So if I have like my ones place, I don't know why I put a 0 in there. We don't need that. If I have my ones place, and then we have our tenths, or even our hundredths, these are a part of the whole, and they're just place value. That's really all they are. So if I had, for example, pick a better color, I had 3 here, right? That's, for example, let's just say I have 3 holes. That's the ones place, 3 holes. Well, if I don't have any tenths or hundredths, right, I don't write my number like this. You've never done that. You don't do that. You just say, oh, I have 3. 3. We just write 3 like that, right? So if there's nothing in these place values, the reality is I don't need to show it. But if someone's like, well, let's think about the number 3 and let's write an equivalent decimal, you'd be like, oh, well, okay, I do need to show 3 as a decimal, which is 3 wholes and 0 tenths, because I don't have any tenths. This is equivalent. Look, they look different, but they're exactly the same. And so the cool thing about equivalent decimals is really it's this idea of what we call the trailing 0. Trailing 0, which means I can put zeros in as placeholders, and I can have them go on forever because none of this matters. These are just a bunch of zeros. Those hold no value. No value. So I can just write them there if I want. And the thing is, it's exactly the same. 5 is the same thing as 5 and 0 tenths, right? If I have $5 in my pocket, I have $5 in my pocket. I don't say I have $5 in my pocket and 0 cents, but we can write it as that. So it's equivalent, it just looks different. I could also write it like that. That works. Or this, that works. Could I just change colors? It's too many same colors. Could I write it like this? No, because look, here's the ones place, here's the ones place. Well, that's not the same value, right? So as long as we keep something in the ones place or even in the tens place, if I had like 35, I could write that as 35 and 0 tenths. That would be my way of equivalent. So there's like really just a trick. If I have a whole number or even a decimal, I can just think about the trailing zeros. So let's say I have 3/10. Oh, that's the same thing as, right? Same thing, nothing changes in that place value. But then these trailing zeros, like that's the same. 3/10 and 300 thousandths, they're the same. They're really generally the same because these zeros mean nothing, right? If I had 54, say I just had something like this. Well, we could just think about an equivalent way is getting rid of those zeros. That's the same. This is also the same. Sorry, I squeezed it in there. And again, if it was a whole number, like 8, no, I can tell you what, let's do 518. There's a whole number. Well, an equivalent decimal would be 518 and 0/10, right? I did not change my value. I just put a 0 in to the decimal as a placeholder. I could also say it's equal to that. That doesn't matter. Trailing zeros it doesn't change anything. They're just there. They're just filler. It's just there, right? But again, remember, if I had 518 and I said, oh, well, 5 and 1800ths, that's not true. This is not true because again, look, the 5 is now in the ones place where I have an 8 in the ones place. So now everything changes, right? And this changes the value. The value changes here, which is why that doesn't work. So again, remember with equivalent, it's looks different. We'll reverse it. Looks different, but it has the same value. So when someone says something about equivalent, just think about how can I rewrite this? Equivalent. How can I rewrite this so that it has the exact same value, but it looks different? And that's how it works with decimals, just that idea of trailing zeros. I really hope that helps. Continue to ask the questions, and as always, thanks for being here.